this is the Professor, CBMD PhD, and today's Thursday, June 8, 2023. It is 9:33 and 7 seconds, p.m. Eastern Daylight Time, and today's research, aerosols and holograms. So let's do it here. As free-flowing aerosol particles, identified using holograms lasers. Date October 3rd, 2017. Source, Kansas State University. Holographic images of free-flowing air particles may help climate change and biological weapons watchdogs better monitor the atmosphere, according to a recent study. The images are made by two overlapping lasers that can be mounted on unmanned aircraft to monitor the atmosphere. We have these small little chunks of particles floating around in the air, and people want to know what they are made of. But if we disrupt them, it might change their form. Until now, there hasn't been any unique and confident way to confirm particle size and shape properties in their natural form. We have solved the inverse problem. As referring to the problem as work backward from results to cause, the inverse problem with aerosol particles was largely educated guesswork based on mathematical calculations. Researchers could not objectively define free-floating aerosol particles because merely capturing a particle and looking at it under a microscope can change its physical shape or size. Now they can bounce like waves off the particle and measure the deflection. The method explained in the publication takes holographic images of particles as they float through the air using two overlapping lasers, one red and one green. The green laser is a traditional method that can be used to measure the light deflection by providing the red laser. They also get a 3D image that can subsequently account for a variety of particle shapes. They get the two properties, size and shape, that they've always wanted to get. They still have all the advantages that people had for the last 50 years. Light scattering, contact-free, and measurements can be done rapidly, and then they put it on an instrument and fly it around the air. Researchers are working to put the laser setup on unmanned aircraft to measure free-flowing aerosol particles in the atmosphere. Removing the particles from their natural environment can change the particle form. And for example, if the particles are frozen in the atmosphere and scientists collect them to bring them back to the ground to study, the particles can melt and change their shapes and sizes. If we think about climate science, they want to know the size and shape of particles floating in the atmosphere. This information can help climate scientists account for how much sunlight those particles scatter back into space or absorb, and if they absorb, how much it will heat up the surrounding atmosphere. And this is the Professor of Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.